The derivative of a constant times a function is the constant times the derivative of the function. So basically, if you have a function of a form c, that's a constant, c times a function f of x, you can just pull out that c in the front, that number in the front, and multiply that by the derivative of f of x. Okay, so I'll show you some examples. When you're trying to find the derivative of 7 times x to the 4th, we use that power rule. We're going to bring that 4 down to the front, but we will have to multiply this 4 by 7. So the new coefficient will be 28, and you get x to the 3rd power because you go down 1 from the old exponent. So that's what this theorem is saying. You bring down the exponent, but if there's a number in front of it, multiply it, okay? So what if, this one's a little bit tough. So for this one, you see there's no exponent, right? You have to rewrite this in the exponent form. So keep that -5 the same for right now. But instead of square root of x, because square root of x can be written as what? X to the 1/2 power, right? So write it that way first, and we're going to take the power rule, okay? So if you take the derivative of this, you bring down this exponent of 1/2 to the front, and you will have to multiply this by 5, okay? So if you multiply -5 times 1/2, you will get -5/2. And the exponent will be 1 less than the original exponent, and this will come up very often. 1/2 minus 1 is -1/2, okay? So that's going to be the new exponent, and that's our derivative. So this is the answer. All right, let's see the next one. Ooh, now the x is in the bottom of the fraction, right? So let's bring it up first. So this is the same thing as taking the derivative of -45 times, now look at this. I'm trying to rewrite this x to the 4th power that was in the bottom of the fraction. Write that as x to the -4th power, but no longer in the bottom of the fraction, okay? Now let's use the power rule. Bring this -4 down to the front. You're going to multiply this -4 by -45. All right, hold on. Let me get my calculator open on my cell phone. So if I multiply -45 by -4, you should get positive 180. So the coefficient will be 180 times x to the, now remember to go down 1 from the old exponent of -4. 1 smaller than -4 is -5. So that is going to be the answer. Now look, if you want to rewrite this back in a fraction format, you can write it as 180 over x to the 5th power in the bottom. Both are good. Both are thumbs up, okay? Both are good. Okay. All right, let's look at a couple more examples. Oopsies. Where did that go? Okay, back over here. Well, it says try these, okay? So maybe stop the video and try them. I'm gonna show you the answers in just a second, okay? All right, say that you try them. What did you get for your answers? The first one, this has to be y prime equals 90 x to the 8th power, okay? Well, next one, if you bring down this exponent of 3 so that it can be multiplied to the original coefficient, you have to do what? Pi times 3, right? So y prime is going to be 3 pi x to the, go down 1 from the old exponent, so it should be squared. So that's the answer for B. And for this last one, hopefully you rewrote. You rewrite this y as 90 times x to the -5th power, okay? That's the first step. Now you take the derivative. you bring down this exponent of -5 to the front, and you multiply 90 times -5. 90 times -5 is -450. So you write -450, and x is getting raised to the what power? -6 power. So that's it for this page. We looked at some examples that had theorem 2, when you had a constant times a function. It's basically the same power rule, but when that exponent comes down, you have to multiply to the original coefficient that you had in the problem. Okay?